with these formulas, you can see the position here is just S of t, or sometimes you're going to see it just x of t. They may even call it y of t, but it's just a singular expression, okay? It's one function. Whereas in vector forms with the parametric, you're going to have your x of t and your y of t together, where t is the parameter, okay? So velocity, we know, is just the derivative of position. Acceleration is the derivative of velocity. So when we have these in the vector formats, it's going to be very intuitive. Again, we just derive and derive all the way through. So nothing too crazy. Total distance, we remember we put those absolute value bars because we absolutely love total distance from the inside. And that's when we're in rectangular. Total distance when we're in like the vectors or the parametric is this arc length formula. Do you remember that? Okay, so do you remember speed back in rectangular is we just basically get rid of the integral part, and speed is just the absolute value of velocity, right? So this is the new formula, and we won't really practice this until tomorrow, but I want you to see how it's the same. We just get rid of the integral part for the speed. Same concept as in rectangular. Does that make sense? Okay. What if I was just to integrate v of t from a to b? What's that giving me? It's the change in position, or just, what's another word? So this is equal to the change in position, which is also called the what? I heard it, displacement. Right? So if I drop the absolute value bars, I'm just the change in position or displacement. When I have the absolute value bars, I am dealing with total distance traveled from A to B. Good? Okay, so I'll let you just you can read through this little part. Unless you'd like me to read for you. Who wants me to read aloud while you read? Okay. Speed is the first derivative of distance with respect to time, where velocity is the first derivative of displacement with respect to time. Interesting, right? Speed and velocity are related in much the same way that distance and displacement are related. Speed is a scalar and velocity is a vector. Thus, the instantaneous speed of an object is the magnitude of its instantaneous velocity. Speed is the absolute value of velocity. Speed can only be positive or zero. It tells us how fast a particle is moving. So if I look at this, if this is my position versus time graph, right? How much, where I'm located. When I take the derivative, where does this come from right there? From the what? Yeah, that slope, right? Whatever the slope is of that line, that's where that's located. Yes? And then this part over here, whatever that slope is this part. Yes? So velocity can be positive and negative. But when I go do my speed, where do I move? That stays there, but where does that green part go? It has to become positive. Okay? Make sense? Okay, another review from AB. When is speed increasing? Then what happens? Okay, velocity and acceleration are the same direction or the same sign, right? So we could either have positive, positive, or negative, negative. When is speed decreasing? So if I had B of t and A of t, so if I went positive, negative, or negative, positive, the speed would be decreasing, right? And I really like this little part with the cars, it helps you see a little bit better. So if the car is speeding up as it moves to the right, it has a positive acceleration. So you can see again, we are speeding up. We're going in the same direction. And B, this car is slowing down as it moves to the right. Therefore, it has a negative acceleration in our coordinate system because its acceleration is towards the left, so the car is decelerating. The direction of the acceleration is the opposite of the motion, right? So it's just kind of, as you look through, it's like, oh, yeah, when you kind of think of it in real life, you can see it with those two as well. Okay, so some other things to remember. Average velocity. Do we ever use the velocity function? No, unless we are doing what? Okay, so average acceleration is the change in velocity. Average velocity is the change in position over the change in time. So just pay attention to those. Make sure you kind of see, hey, average velocity is the change in position. Average acceleration is the change in velocity when we're doing that. And then just a little kind of key notes. When you see it initially, you think time is 0. When you see at rest, you think velocity is 0. Okay. So remember, at rest is when both are 0 simultaneously in the parametric, and then at the origin is when we set the equation equal to 0. So just kind of thinking through that. So now we're just going to do a ton of AP problems back from AB material, just to get all of that back in our brain again. And then tomorrow we'll do the new stuff with PC, which really the only new thing is the speed. We've been doing the rest. Okay. So if the position of an ant traveling along a horizontal path at time t is 3t squared plus 1, what is the ant's average velocity from time 1 to time 6? So do you know what formula you need to use? Okay, go set up your formula, plug it in, and see what you get. And we're going to label just for now, just for practice, even though it doesn't say. Label your answer. Yeah. You. So what did you guys get out there? Oh, hi Bob, come on in.
Excuse me, young lady. Victoria?
Thank you.
Hey, sorry, Bob.
You're okay. Alright, what did you guys get out? D21. What would be the labeling? Units, oh, it doesn't say was it the time. But it's like, let's say that we were in meters and seconds, then it would be meters per second. When would it be like meters per second squared? Okay, average acceleration. Okay, sorry. I'm not thinking this. Okay, let's try this one. The position of the particle traveling along a straight line is x of t equals that guy. Sorry, I forgot to say that. On the interval from 0 to 10. When is the particle farthest to the left? So they're looking for the position is going to be a minimum, basically. So, you know what to start on? You have to go find your velocity to get the zeros of it for your critical numbers. numbers, and what else are your critical numbers? Which are the endpoints. Okay. Good so far? So remember, when we're looking for the absolute max or the absolute min, we don't really need to set up the number line. We need to plug them back into the original. Okay? So relative is when we would set up the number line and then discuss what that number line represents. But absolute, we go back and we plug them into the original. Zero is easy to plug in, right? So 1. Doing your own mental math, you're not just copying what I write, right? Okay. So I have one more. I have to plug in my 10. Probably just going to gauge if it's going to be positive or negative since I already have a negative. Okay. And what do I know that answer is going to be positive. So, but I really wanted to find it all. It's not too bad. If I was looking for the absolute max, when it's farthest to the right, I'd have to find out what that is. So, where is x of t at minimum when t is 5? Anybody one more time on this one? Okay. So this one I really like. So it says choose the integral expression that would result in the total distance. So as soon as I see total distance, and am I in one, like a rectangular or parametric? Rectangular. So what's the formula in rectangular? The integral from a to b of the absolute value of b of t dt. Do you see absolute values in any of those? No. So for instance, then, let's say that I had some function. Let's do x squared minus 4. Okay. and I'm going from 0 to 3 again. And I'm trying that my velocity is that x squared minus 4, okay? And I'm trying to find this absolute value of v of t from 0 to 3. What is going on that I would need to do if I can't use absolute values? Okay, so I would have to flip that part right there, yes? So that part right there is actually going to be flipped up. So I would have to go from 0 to 2 and do what with that velocity? Negate it. And then add on from 2 to 3 and leave it alone. And that would be the absolute value, yes? Okay, so you guys try it for the one that you have. No calculator still, you can do this. That's really to skill very much or whatever, but we've got the idea, right? Did everybody get that 0 to be the ln of 6? Raise your hand if you're like, I don't know where that came from. Oh, okay. Somebody else? I don't know where that came from. Okay, so I need to go from where to where? 0 to the ln of 6 and do what with that velocity? Negate it. And then add on from ln of 6 to 3 and leave it alone since it's already positive. So which one is that? C. C. Everybody good? You're like, this is child's play, DeRose. You remember this stuff? Or are you like, yeah, this is a good review? Just really one of them.
Oh, this is a good review.
Yeah? Okay. Like, should I keep it in here for them next year, or should we just jump into BC?
You should keep it in there.
Okay, so now we're getting to the free response. So this is the graph, and as I, when I do this, I always say, oh, that's velocity. I need to make sure I'll, circle it so I don't think it's a position graph or anything. So this is velocity. So that's the first thing I kind of do. And so it says it's velocity from 0 to 8, and then it gives me this part. So at t of 0, then I get out that the object is 5. So basically that x of 0 equals 5. Or you could say s of 0. So that's what that part is telling me. Yes? So now let's go to the first one that says, when is the object at rest? So what do we think of when we think object at rest, where v of t equals 0? And they gave us the graph of v. So where does this occur? What's 5 and 8? Okay, when t is 5 and 8. Yes? Alright, evaluate from 1 to 6 of v of t dt and explain the meaning of the result. Go ahead. Gonna have to go find some areas.
Joe, can you scroll back up to the graph?
Okay.
My notes.
And it wants me to go from where to where? 1 to 6. So we should get out 4. So it's not starting at 0, which is the tricky part. It's starting at 1. So that guy from 1 to 6 of v of t dt is 4. So I have 3 plus 2 minus 1. So we're not starting over there at 0. And the meaning, so Josiah, you had one word, which was, is that enough for credit? No. So that is not the meaning. It's the displacement of the particle from t equals 1 to t equals 6. Okay? Or, instead of displacement, could you say it is the change in position of the particle from t equals 1 to t equals 6? Either one of those is fine, but just putting change in position or displacement is not fine. Does anybody say, hey, I want to read what I wrote and see if it's right? Are you okay? Okay, look at your neighbors on the left and read theirs and see if you think it's okay. So we pass theirs to the left, or no, to the right. Pass it to the right so I can see it, and read what they wrote and see if you think it's okay. Help them out if you feel like it's not okay. So now going on to part C, it says, what is the position of the object at t equals 5? There's something that should be jumping into your brain that we have been doing over and over to help you with this. Fundamental theorem of calculus. Go. So set it up. What are your bounds going to be? One of them you know, and one of them you want. We know 0, and we want 5. Oh, come check. So we know 0, and we want 5. So that's where I put those bounds. Yeah, that's fine. You can do that. Basically, essentially what we're doing. We're just yeah, and some of you like to just say, hey, x of 0 starts here. The only thing I don't always like about that is sometimes the one you're looking for is here. So you can't just put the one that you know. That's why I always like to set it up. Okay? Alright, so we want the 5. What do we know this guy is here? From 0 to 5? 6. What do I know 0 is? 5. So what does x of 5 end up equaling? 11. Good? Okay, so now D wants the total distance traveled. Go. You know that formula. You're in a rectangular. So I know that any of the negative has to become positive. So it's no longer just the displacement. It's how much total we want. Whether we backtracked or not. Thor, what'd you get? Perfect. Thor got 10 and he is right. I tried to do the long hair for Thor. He's kind of got a couple curls. All good? So last one, it says at t equals 2 is the object speeding up or slowing down. Explain your answer. And I can't tell you how many of you got this wrong, even though you understood the concept, you didn't quite write it correctly in the explanation. What 2 things are you wanting to find? So speeding up or slowing down at 2. So what 2 things are you wanting to find? Okay. So we are trying to find A of 2 and B of 2. Do I even have to find them?
Just like this.
We just need to know their signs, if they're positive or negative. But I'm going to write out the word positive, and I'm going to write out the word negative. Okay? So we go look at our graph. This is the graph of V. And 2 about right there. So is V of 2 positive or negative? Positive. What about A of 2? I don't know V of 2, so I can't derive it to find A of 2. It's the slope. Okay, so the slope are the A of t's, right? So is that slope at 2 positive or negative? Positive. So both of these guys are positive and positive. So what is my answer then? Okay, the object is speeding up. Now, I'm going to write something and I want you to tell me what you think after I write it, okay? That's a t. So I said the object is speeding up at t equals 2 because a of t and v of t are both positive.
Well, you've
But-
already defined that t equals 2.
Well, I said it's speeding up at t equals 2, but my reasoning was because a of t and v of t are both positive. So, Boar, is this right or wrong?
I know it's wrong. What do you say?
I did. So I said the object is speeding up at t equals 2. But did I imply that a of t and v of t are positive at 2 in any way, shape, or form here? No. Okay, so I could have said are both positive at, well, it's not true that they're positive everywhere. Oh, that's what it means, basically. So I could say at t equals 2, or I could have put a of t and b of t are both positive. Or, sorry, a of 2 and b of 2 are both positive. That would get me the credit. Do you see the difference? Even though I wrote at time 2, I didn't imply that they're both positive at 2. Got it? Okay. Got it, Bar?
Yeah.
Okay. Okay, next one. I think we only have this one in one bar, right? Stay tuned. What's next?
I know.
Oh, we're gonna have a lot of work time. It's nice. Gosh, it's becoming so soft after spring break. First, the homework. Now it's just goes on. Gosh.
Oh, don't worry, Mr. Rose. Eventually you'll get working us from Alabama again.
Okay. Ready? Do this one with your group members.
That has me worried about this.
Ready? Go. Let's see if you can do it in 2 minutes. Go. Nathan. One fourth then. One minute in. Seconds. Bless you. 2 minutes. Anybody get it? Nope. Yep. Alright. So let's see if you got the derivative. First times the derivative of the second plus the second times the derivative of the first. So I'm going to factor out my t minus 2. So I have 2 times t minus 5 plus t minus 2. So t equals 2 from that part. 2t minus 10 plus t minus 2. 3t minus 12. So t is 4. So that's the easiest easiest way, in my opinion, is just factor out that t minus 2. That's how I taught you back in AB. Okay, last one, and it is a free response. Let's start with A. So, Johanna jogs along a straight path for t between 0 and 40 inclusively. Johanna's velocity is given by a differentiable function b. Selected values of v of t, where t is measured in minutes and v of t is measured in meters per minute, are given in the table above. Use the data in the table to estimate the value of v prime of 16. Done? What if I wrote 5?
I don't feel like you don't get the point there.
You do not get the point. What if I wrote this? Have a difference. And I even said that, even. What was it? Oh, sorry, 40. Sorry. What if I did that? Still not enough. You have to show a difference and a quotient. So if I had v of, where am I at, 16? 20 minus v of 12 over 20 minus 12, do I have a difference? Do I have a quotient? Is this full credit though? No, because I'm still in function form. What if I wrote that? Full credit. What if I wrote this? It didn't tell me I had to. Full credit? Do I have to put equals 5? No. But you see the difference between this and this. This still has functions. This has all numerical. Hey. Door. Alright, we're gonna go here then here.
So it's okay to add 240 minus 3 over 80.
Yes, because you have a difference and a quotient.
So what you said is
No, no credit. You have to have a difference and you have to have a quotient. Okay? Oh, I got it. Okay. But even though this has a difference and a quotient, I can't leave it that way because it's not numerical. It still has that v of whatever. Okay? It's unsimplified in a bad way. So, but if I put just this guy, that's full credit. If I put this, what was that, 8? Okay, that's full credit. Do you understand what I'm saying for the differences? All right. It didn't tell me I had to. Do you want to label? It would be in what? Meters per minute squared, because we're on acceleration. Okay, B, using correct units, explain the meaning of that definite integral in the context of the problem. Let's do that first. Let's see if we can write what that means in context of the problem with correct units. that right. No, why not? Okay, I never said meters. So it said using correct units, and even though I used units here, I didn't use units in the right place for the distance. So we have to use both of them. Otherwise, we get it wrong. So there's two different units going on, meters and minutes. So if I said the total distance in meters, now am I good? What if I just said that she jogged in 40 minutes? Is that okay? Why not? Okay, it could be any 40 minutes, so that's not okay. What if I said in the first 40 minutes? That's okay. Alright, do you see all those differences of how you can lose points? Alright, so there's the explanation. So now see if you can go find it. And you have to simplify if you have all numbers. No. In fact, if you do, I get to thump you. It's a rule. It is. It's a calculus rule. If you try to simplify that Riemann sum, I get to thump you. Okay? Because you're going to waste your time for the other questions, and you increase your probability of making a mistake. Who can tell me the tricky part on this one? What's the tricky part? The negative. And we are in the absolute, right? So we want the total distance. So what are we going to make that guy? Positive. Full points. Did it tell me to cut it? Do I get full points? Even though I simplified some of them, it didn't simplify some of them? Yeah, I can still get full points. Okay? That's how I want to leave it. Done. Drop the mic. Out, right? Thank you. Have a good one. Alright. What'd you get when you simplified, Jackson? Let me hear it. What did you get?
5,600.
No. It's 7,600.
Get him, get him.
Jackson,
I got that.
did you learn a lesson?
No, that's not
Okay.
Yeah, true. Can you tell us to do something we're more inclined to do?
Okay. So now we're on to Bob. Bob is riding his bicycle along the path from time 0 to 10, inclusively. Bob's velocity is modeled by that function, where t is measured in minutes and v of t is measured in meters per minute. Find Bob's acceleration at time 5. 1 minute, go. That's 30 seconds. It's 45 seconds. Full credit? How many of you guys simplified? Oh yeah, that's fine. But, you know what I meant. Okay, so full credit? Yes, I want us to, but is that full credit for this? Do I have to go do 25 and then times 3 and then the 12 times 5 and then put it all together? No. Okay. So this would be meters per minute squared. If you simplified it, it was 15. Okay? But I would just leave it like that. Alright, D, go. Oh my goodness, find the change in position. Average velocity, right? So I don't do the change in velocity over the change in time. I do the change in position over the change in time. Which means I'm going to have to do what to that position? Agreed? That would give me my change in position. Bobbies. Bobs. Bob. I don't know. Why did I put in 100? Ay, gross.
What's the simplified?
I'll tell you in a second. Here, let's do this. I don't, but that one I just wanted to. Minus 0, even if you wanted to do that. 350. If you simplified it. I mean, that's pretty unsimplified. That I have up there. This, okay. This would not get you full credit because you haven't done this operation thing. So you can only do addition, subtraction, division, multiplication, and trig, sine, cosine. Okay? So that is not full credit. That is not full credit because you haven't done that antiderivative. Okay? This is full credit. exponents. So, huh? No. Let's flip it. And if you simplified it, that was 350 meters per minute. Okay, so you get the rest of this class. You can work on your homework. If you're chatting, I'm just going to go ahead and do the